Hi, I'm Stuart. I work for a company called Procona, which is among other things, a MySQL support consulting and development company. I'm at the development end of things. There are other parts of the organization that do support and consulting, and we attempt to have good relationships between those organizations, because it turns out that if you make your support and consulting people happy, then they may recommend your software more. It's very much a company that has an ethos of recommend the best thing for the customer, so that may be not recommending the software we make, which they're free to do. I joined the company in May 2011, and so this talk is basically a wonderful tale through the ideas of what I've done since then. So my job title is wonderful because it's odd, is Director of Server Development, and this basically means I came up with what this actually meant in practical terms was I should ask myself a question. Am I responsible for dollar thing that's to do with development? And the answer was yes, and this is what the job title entailed. And so this is basically the story of introducing continuous integration and modifying development processes within the company and the development team at the same time as still maintaining software releases, having a continuing business going on, and all those kind of things. And it's a war story because witty titles get more attendees. And it's not as much a battle as maybe the title suggests, but it definitely is in some places. And there is probably other ways and more frank ways sometimes of some bits that you can prize out of me if you pry me with very good beer. Or it turns out, good coffee.
Or bad beer.
But it also helps, I'll say, if an organization is open to positive change. So if you manage to work for an organization that is closed to positive change, then just quit and let them die. Like, seriously, it's not worth your trouble. And go work somewhere where you can actually be productive and improve the world. And part of this could be, if you're finding resistance, I would say, push for it. Provide evidence, provide reasons, gradual change. A few tips in there to do that. But at some point, you have to decide that that's too much and leave. So I inherited a bunch of technical debt coming. And so there was, for some of our software, there was a lack of a test suite. For other parts of the software, there was lack of a consistently passing test suite. And code review was much more of a casual affair. So one of the things that I wanted to do was to introduce continuous integration. And this is partly responsible for what I think is a good improvement in quality of what we ship. But there's also a lot of development practices that go with this. So I am absolutely opposed to needless process. It's something that makes me want to hurt people. And at one point I did work for a company that loved needless process, and that's a waste of time. So we don't want to do that because we're a small company and we want to actually be efficient. So it's basically organizing process to be efficient rather than bureaucratic to keep bureaucrats in jobs, because we don't need them. So it's an existing company I come from, an existing development team. So I was the new guy coming in and now telling people what to do. Releases still have to be made. So you can't just sort of greenfield or bulldoze it all and start again, because people rely on your software. Different people have different attitudes inside a team. Some people are very open to positive change, others aren't. Some people sort of adapt to how things go to get better, other people don't. And there's different ways you have to deal with this. So the downside is that unfortunately, at some points, you may actually be in a kind of management position or recommend that this is working, this not. So good luck with some of that. But managing people is as much as introducing part of this process and technology as anything else. I say existing products, yeah, we couldn't shut down anything here. It is also a privately funded company, which is brilliant because there's no venture capital, which is also annoying because there's no venture capital. So you don't have this big company budget to immediately blow on a whole bunch of cool shit because it might help you. You do actually have to turn a profit, or at some point you're not going to be able to pay your employees. I will also say there are 0 development infrastructure people, right? So this is me as director of server development. It's not me as me with a team of people just to get things up for the rest of everyone to do development on it. It is essentially 0 because there's enough other problems going on. We also have what I refer to as negative internal IT resources. To the extent of that a bunch of stuff is actually orthogonal to the rest of the company's internal IT stuff, because I know it's simple and that can work. At some point I was so annoyed. VPNs never work. They're a fucking waste of time. Yeah, I mean, seriously. It's virtually persistent networking, vaguely possible. non-connection. But anyway, at one point I was seriously considering running all of our build slaves as Tor hidden services, because at least that would actually consistently work, because it can get through great firewalls of countries, it can get through, well, it can get through a VPN. But this is probably a common scenario, and it's one of the reasons why I came to talk. It's like probably a common scenario of people in existing orgs, existing products, and existing development teams with different views, and maybe this can help. So a quick overview of what we build. All of our software is free and open source software, which helps. One of them is Percona Server, which is I best describe as a branch of MySQL. Previous life I worked on Drizzle full-time, and now that's most of a hobby thing. But Percona Server is definitely a branch of MySQL. We base off Oracle's releases and add our own patch set. The idea is that it has better performance, usability, and manageability. We also have a product called Extra Backup, and this is online backup for InnoDB. So basically non-blocking physical backup. So instead of getting a SQL dump out, you get safe copying the files on disk. It compiles and links in a lot of InnoDB code, so it actually compiles a subset of MySQL in a specific way and then links that in. It does full and incremental backups, and people want their backups to work, so we should make sure the product still works. And there's other products we do have, but these two are our sort of major ones. Continuous integration, why do we do that? Well, it's really served me well. So the first continuous integration experience that I really had in day-to-day was back at MySQL AB when it was called MySQL AB. And one of the guys got fed up with trunk never bloody well compiling and wrote a tool to automatically compile it and shame people into fixing their code. So this was called push build, because this was Bitkeeper, and on the push it would then pull the tree and build it. So it only did one thing, and it basically pulled it, built it, and did that. And it helped dig MySQL out of a giant hole. For anyone who remembers MySQL 5.0, and especially the early versions, 5.0 could have been a lot worse. Like seriously, trunk never compiled, let alone passed the test, and push build sort of got us there. So this is phase one, I say, of continuous integration if you're introducing it anywhere. Phase one is just constantly build and test trunk and let people see how broken their shit is. Right? Considering that if you don't have it, you probably don't know how broken your software already is. So simply building and testing is a good first one. You don't even have to change anything. All you have to do is set it up in a corner somewhere and build it, and continuously build it sort of as fast as happens. And this can be like on your workstation, publish it out, and then just like start badgering people, and then at some point, you can start whinging to management of like, we're shipping stuff that doesn't even like compile. Like, we have a release crunch. Why are we having a release crunch? This is silly. And people get a better idea that it's a good idea. Run the test suite is always another thing. It's great to have a test suite. Run it. Can you run concurrent builds on the same hardware? That can be a good thing to parallelize things. Most people's test suites aren't highly parallelized. Reading out sporadic failures is always good. Difficult to run. This can be a thing. So we went from when I joined, the Extra Backup test suite was run by one person and probably only ever ran on one specific set of hardware and environments. And we've gone from that now to it can be run it can be run anywhere we ship with any version of the server software we support backing up from, and it actually runs and passes consistently. So this is another thing, like once we actually don't just have QA people run the test suite, make everyone do it, as in sit down when you're doing this and attempt to run it. And then when you realize that is nightmarish, I wouldn't do these things on my own laptop with sensitive personal data on it, you possibly want to fix those things. So that's definitely a good thing. So start fixing things. So this isn't like an instant thing of tomorrow you're going to have continuous integration everywhere, but like start building trunk, start running the tests, and start fixing things there. And this will give you small wins each step of the way, right? And sometimes I will recommend like be an asshole about things. Like say you broke it, like fix it, we can't ship rubbish. It's not like be a complete asshole about it, it's like be persistent and insistent that perhaps that your product should work as advertised. And definitely this can introduce things along the ways, and people will say, it doesn't work. And you may get people starting to, when they're actually doing development, actually continually check out trunk and develop on top of trunk instead of that snapshot 3 weeks ago that actually built for them. And this was a big problem inside MySQL as well. So inside MySQL, we started to have a lot of developers, at least a lot for the time. And so we had this idea of team trees, because trunk was going to have congestion. So each individual team had their own trees, and you'd merge into that and then merge these into trunk. So this is something I really don't recommend, because it basically means no one ever runs trunk except customers. So no developer ever runs what you actually ship, or even close to what you actually ship. They run their own tree, which at least they personally know and work with every day, other people who could possibly break it and go and hit them over the head. So you're now running a bit behind of what last worked on a team tree, which is a subset of what you may ship sometime in the future. And then you'd suddenly merge these team trees together, which is always someone who didn't really know how all the merges worked, and then you'd pull them back and nothing worked again. So MySQL 5.0 could have been an even worse thing, but this was the sad thing was this was much better than what it was before. So don't do team trees, but it's a nice idea when you're at that level. For Drizzle, we discovered a great tool. It was then called Hudson. So after we forked MySQL, and we found this great tool called Hudson, because basically we thought, well, with push build, it was still sort of closed and didn't do a bunch of things, but we found this great open source project that had the great benefit of having a whole bunch of other people maintaining the software, not us. Because we were, again, a small team in like the research arm of Sun, and we needed to, now make good on our promises of what we went off and did a Skunkworks project and then suddenly announced at OzCon rather than inside the company. And make it work. So Oracle, of course, screws up open source software projects. That's what they do. So it's now Jenkins. And it looks something like this. And one of the great things about Jenkins is the fact that it's actually a web UI. So when you're wanting to introduce it to somebody, you can actually introduce it to them very, very easily. Because it's like, oh, here's a button that says it's blue. Here's this. You can click this, fill out a form to build a branch, that kind of stuff. So there's a real low barrier to entry. And this is especially true if you're starting it up yourself. You want to actually go and set up Jenkins to compile your software. It's really trivial. As long as it's as complex to set up as your software is to build and test, I should say. So if it's annoying to build and test, then it's going to be a bit more annoying to type all those damn commands in. But if it is, for example, /configure make, that's really easy to go and create a new job. I want you to run the commands /configure and make, and it will then basically start working for you, which is great. The other great thing is it's free software because, did I say we have zero budget? Well, not zero, but not a lot. The flexible web UI is pretty cool. So you can do different numbers of executors, different slaves, all these kind of things. You had some people want BuildBot and the like. I'm like, text config is great on two levels. One of which you reach a certain kind of scale when you're going to have lots of people. The other one is if you like to hand it files and then break your thing and never track it. And also not have people be able to join it. So one of my goals was to then have documentation team using this. So then automate documentation build and deploy and testing. Then also have QA guys running it and doing that. So to be able to have QA guys simply be able to enter in the few commands, run benchmarks in interesting ways, where to graph it and have it go. And we can all do that simply via web UI, and it means I don't have to tell anyone how to do XML or YAML or something. So it's a great flexibility for a certain amount of scale. If you get to OpenStack scale, odds are you're going to have a team that can do a whole bunch of other stuff and do more automation and learn about actually doing deployment of things. But when you're small enough, Jenkins is great until probably a few hundred people. It's also easy to install. You can just have apt-get install from their PPA, or you can get what's called a war file, which is something to do with Java war thing. Realistically, Jenkins is the only reason for Java to exist anymore. Everything else, it should die a horrible death, and I'm glad that Oracle's on the way to doing that. But apart from that, Jenkins is about the only useful thing in Java. The also great thing is plugins. There's plugins for just about anything you ever want to do. Everything from turning on red and blue lights in a physical room to say whether it's building and passing, or to get a toy rabbit thing to have its ears go around in circles, or speak things out and go into IRC and make Skype calls to you to tell you the build's broken, and you name it, there's a plugin for it. The plugin actually thing is so one of the downsides of starting to use the Bazaar plugin for Jenkins was Monty said, you're using this more than me, congratulations, you're now the maintainer. And I'm like, you bastard. So I now maintain Java software, which something should be said about.
You than me.
But plugin stuff do anything. So any version control system, you can even spin up stuff to do certain things on Windows stuff, and basically you have slaves. And you can have slaves running via SSH, via a Java web start clicky thing, run as a Windows thing if you have to build on Windows and the like. Anything there, it's basically anything that can run Java can run a Jenkins slave on it. And that's basically machines that will build jobs on. So this is a screenshot of our one, and we use static slaves here, which I'll talk a bit about later, but you can also have it spin up cloud machines on demand and all kinds of other things. We currently have about 32 build slaves in there, most of which are VMs on machines, so we may have like 16 physical boxes, I'm not sure. Here's a downside to it. I said negative internal IT support. So it's a cluster of 32 machines plus VM hosts that has 0 dedicated sysadmins, because we have a giant, now heterogeneous cluster of machines. And it turns out that requires some effort every so often to massage it. But yes, Puppet is as brilliant as anything, I'll tell you. So we ship multi-platform software. So Jenkins is of course multi-platform when you run anything, but we ship multi-platform software, which is good because Jenkins has this feature called matrix builds. So you can say, build this job with these different configurations, and one of these can be label expressions. So slaves can have labels on them, and you say, well, now build my software on Debian 6 32-bit, Debian 6 64-bit. I say 32 64-bit because apparently no one gives a crap about anything but x86 anymore. And then you can build across CentOS 5, CentOS 6, and all those matrices, which is great. Until you get to the point of when someone has decided to support just about every combination of anything. And this is the current build matrix for extra backup. So this is about 12 supported platforms, and then it's times 11 different variants. So it's InnoDB in MySQL 5.0, the built-in InnoDB in MySQL 5.1, the plug-in InnoDB in 5.1, in Percona Server 5.1, in Percona Server 5.5, and using Galera Cluster in Percona Server 5.5, and then some of the debug builds for people who want to do this with debug. So that's 12 times 11, which equals 132 different builds. So building trunk extra backup actually fires off 132 independent builds.
How much does that cost?
How much does that cost? That's an interesting thing, yeah. EC2 can get into expensive. So nobody had actually seen this before. When I plotted out to do the initial build, okay, it's across these versions, and this is just one point release of each of the major MySQL versions, right? It's not testing if 5.1.15 works as well as 5.1.67. It's just pick one and go with it. If you did the other ones, it'd be insane. So needless to say, actually building extra backup is, I best describe as a distributed denial of service attack when you build infrastructure. It really is when you start to do multiple builds, right? You do like a staging build and going in there. So one of the great things was slaves in the cloud, and this is what you do first off until someone sees the build from EC2. So this is great. It dynamically scales out. On demand, you build without fail. With suitable size matrix, you start building a lot of EC2 machines. And depending on how frequent your builds are, right? So the minimum billing increment's like 2 hours, and then it takes 30 minutes to like spin up the instance, and then it takes you an hour to run the test, and then no one runs a build for another 3 hours, in the 2 hour time the host is up. So every 3 hours you spin up another thing, and 20 of them, and it becomes expensive. So instead of spending a few $1,000s a month on EC2, you scavenge machines, lie, cheat, and steal whatever around to start building them on your own infrastructure. It also has the benefit of it can end up being a bit more reliable, simply because you stop trying to hack together some magic apt-get install line to put in the the boot. Hey, on boot on this VM, do that kind of thing, and you actually start to write a Puppet manifest or something ridiculous. People played around with private cloud things.
I was just about to suggest that.
Yeah, so it turns out I let them experiment with this, and when they came back like a week later of just working on it and was nowhere near having anything working, it's kind of like, it turns out that none of the private cloud things obeys like a 15-minute install rule. The golden rule at MySQL was you should be able to download the software and have it running within 15 minutes. And it turns out that this gets you users. All of the private cloud stuff currently now makes me want to go and hurt people who I know who work on that, because it's like, how do you install this thing? I'm not a dumb person. I'm a smart person who knows how this stuff works. I can't get it running. So it's great if you want to run a big data center of cloud. It turns out that it's just way too problematic for a little thing, at least so far. So hopefully in the future that may change.
Robert's fixing that.
Robert's fixed that, yeah. So we had this a couple of years ago. So static build hosts are brilliant because you can easily tear them down and just have Puppet deploy them again easily, so you can click through the Red Hat installer and do it there. And this has been pretty much fine for us. We did have problems with not having enough resources behind it, because it turns out when you're doing database software, you're restricted by IOPS. That may or may not be a problem for anyone else's software, but it is for us. And our Puppet script's pretty simple. It installs a set of packages we need. We manage these via, it's just using KVM as virtualization, using Virt Manager. So you can use libvirt command line thing to do it. And this has the benefit of you can remotely run a GUI to administer it and just SSH tunnel everything through, which is wonderful. We can even have developers SSH into these hosts, so if something breaks on a specific platform, we literally have a small Python script that goes through the group on Launchpad that is our developers, grabs the SSH keys out of Launchpad, writes an authorized keys file, and deploys this to the Jenkins slaves. What do you think? What? And you're like, no, that's actually really useful because it's not relying on like some LDAP infrastructure or something else that would be run by internal IT and never work properly. Or only work properly on versions of various PAM things that aren't in your Linux distro. Because remember, heterogeneous stuff, we can't say you must run this Linux distro. It's like, well, our customers don't run that, therefore we can't. But this is actually a pretty useful thing to do. Puppet is completely worth it for this. Doing it manually just means as soon as you have to add a package during development, it screws up. So just go buy the Puppet book written by my friend who should give me royalties for it by now. James Turnbull's book, Pro Puppet or something. Start going that, play with it a bit and start going. Don't worry if your Puppet's ugly, it will be fine. Process changes. Basically, I wanted to help ensure quality of the software. So the big telling thing was early on, I went to what they called as global services meetings. So it was all the support staff in one room, and you go, right, who here actually recommends one of our products to their customers? And for one piece of software, like no one put their hands up, and you're like, shit, there's like 80 people in the room and not one of them are recommending software we ship. There's a problem. So we want to have more quality software. And part of this is you want to have a feedback loop. And so one of the things was, of course, code review. Hopefully you do this. If not, introduce it, even randomly and kind of passive-aggressively of sending people email and reviewing their code for them that they've just pushed. May work. That may not end well, or it may end well. You can take it to an extent of certain things of like, if it really doesn't pass it, just back it out. But that requires you to be in a dictator position on the source code, so that can or may not work for you. At the very least with code review, even if you don't code review it closely, at the very least you know what's going into trunk. Right? So one of the great things is that even if you don't spend does it matter on each of these calls to get all the error codes right, at least you have an idea of what's going in. So when something new comes along, you have this sort of vague memory of some bit of code that went in that was around that area. So at least you start to have sort of organizational memory of what's going in. And one of the things that I've loved to do also is put junior developers on code review, and it will take them a bunch of time, but then they learn what's going on. So they mean this change and start to see more of the code and force them to read that and see what's going on. So they may or may not come up with any useful review comments, but it's at least getting them to learn. So we currently have junior devs to do code review. We encourage that a lot, and only a senior developer can like act that to say, yes, it can go in. One of the great things we discovered during Drizzle, and we still use it at Bacona, is what we call parameterized builds, or param, because that's almost 3 characters, and all Unix commands must be 3 characters or less. So we have param builds, which is very simple. Jenkins lets you set certain parameters to a build job, and one of those you just put in is like BZR branch, and then the build job just branches, $BZR branch. And the idea is that when you're submitting code to review, we just use Launchpad because it's software maintained by people who aren't us and run by people who aren't us, so our negative IT resources don't get further used running a code review system or anything there, and it sort of just works. So it's not perfect, and you sometimes look at like all the Gerrit features like, that'd be great, and then you suddenly realize, no, I don't want to administer a box running Gerrit. I really don't want to do that. So the parameterized build was the idea is you just push a BZR branch up to Launchpad, and then you go and fill out the web form with the branch you want to test. And we currently now have 2 extra fields on there as well, which is like parameters to the test suite if you're wanting to try and debug something. So you're wanting to debug something, but you don't want to burn a hole in your lap. So you just tell the parameters of what to build and want certain things, and go make machines on the other side of the world build it for you, and you go to bed. So param build was the idea is that you build and test before you put in a merge request, and then you just put in as part of the, please merge my code, here's the URL to the Jenkins build. So the first thing you do as a reviewer, you go click there and, oh look, there's failing tests, needs fixing, and you're done. And it looks like you're a really efficient reviewer. So this is what it looks for Bacona Server 5.5. So you have MySQL test run arguments and extra options to CMake. So you could actually run the whole test suite by doing like the funny mutex debugging thing in InnoDB and the like, and that's really easy. So you can just have other ones of these jobs, and they're simple. Jenkins also lets you say, hey, for this job, use the build steps from another job. So this actually just references another job for how to build it. So if we change how to build the software, because it's not just configure make, unfortunately, we just change it in one place and everything else changes as well, which is great. So here's an example of the merge request from Launchpad. We just have a URL at the bottom, and we can go and check that it worked. So I love that the OpenStack guys have this all automatically firing off and coming back. I absolutely love it. I just don't have a team to make that happen, and so this is as close to that I can get with 0 to negative resources. So this is something to also consider. Like, this scales pretty well. The other idea is, of course, that you can pretty easily see how good or bad the code is and in that kind of thing. The next thing is we do staging builds. We came away with the next step. So I was doing these for a very long time just manually, of merging it into a local tree, pushing it up and firing off a parameterized build. The idea is that you integrate, test, and then push the trunk, so you ensure that trunk always passes, as opposed to, yeah, we just merged 4 things and independently they work, but together they don't. It also does a bit of final review, because then I could be sort of the gatekeeper of what's going in, and this was very useful initially, so you could at least have an idea of what kind of code was going in, and you could start to, oh look, you didn't actually review this properly, or you did something silly along those lines, or yes, we need someone else to look at that. Is introducing code review, it also kind of helps as someone there to force the issue. The idea is, of course, that bad code never hits trunk. We have a gated trunk now, essentially. Every developer still has the permission to push the trunk. I haven't taken that away from everyone yet, mainly because I wanted to leave it open for a while to ensure that the process itself is working correctly before we remove that away and make it hard to sort of subvert the system. And we do this simply through a couple of Jenkins jobs. The idea is that no one ever pushes directly. We now have a job that is called kickoff. So you basically say, here is a branch I want to merge in. It then creates a staging branch up on Launchpad, fires off another job, which grabs that branch and runs make and test, and has another branch that also runs, builds binary tables, which are then copied to another machine, and it runs performance regression tests. So you can actually then, as part of your staging, do various things. And the idea is that, if all the test passes, then it automatically fires off the next one, and eventually you just get the email notification from Launchpad that your merge request was merged. Of course, this requires all your tests passing all the time, which we're mostly there for most things. Also, the idea is you can then have a complete audit trail. So when you find a revision later on, or you see something that's like, this thing broke something, why did it go in? And you can go back and then see that, oh, okay, so it was run, this job got it merged in, so this person kicked it off, this was the merge request behind it, this is what the test passed and which didn't, and then you can actually see, okay, well obviously we were lacking some testing or something like that. This is especially before we have, performance problems in database software is a big thing. So for us, that's something to go back and try and find out what's going on. And we can also then, as we go on, if anyone attacked our source control stuff, it turns out our software is used in a lot of places that are very high value to attack. So we really don't want people injecting random crap into our source control system. So this would be a way you could actually go back and audit how things went in and make it very much harder to forge. So automated staging was really easy to set up. I made the mistake of thinking that would be hard. It's not. I mean, really, it's a web UI, click, click, trigger this one after the other. And it was really easy. You make a fake username on Launchpad, and you upload an SSH key for it, and then you have a machine somewhere with this SSH private key, and it can do the pushing, and you're done. So this is really not a bad thing to set up. So definitely as phase 6 in the introducing continuous integration, go and do that. Builds can be triggered by multiple means. BZR polling is one. So it basically says, is there any new revisions? Is there any new revisions? After another job is done, and that's what I use to construct the steps to do gating properly. Time-based is very good. For example, we have longer benchmark runs to do regression testing. So every day we basically run a 20-hour benchmark. And we just have that go, hey, kick that off at midnight on a dedicated machine. So with Jenkins, you can do that as well. You can say, only use this machine for tied jobs and only run one concurrent job, in which case it's perfect for doing performance regression benchmarks. We also have another great thing, which is with the gated trunk, we have a sort of bypassing step for documentation changes. One of the things was we eventually integrated the docs with the source, which is great because sometimes that means the documentation can get updated along with the code change. And so we bypassed the full build and test of the entire database server when we were just doing docs changes, because hopefully it's still the same as the previous revision. We also have triggers which auto-deploy documentation. So after trunk gets built, it then fires up a job which then pulls the docs and rsyncs it up to the web server. What I said about negative internal IT resources, you don't always get a memo that they've changed the web server and that now points to a machine that doesn't point to the website. So yeah, that can be fun too. But in theory, it'll automatically deploys it all the time. The idea was to automate all of the things because we're a resource-constrained small team trying to achieve a lot of stuff. Let's automate as much as possible. So pushing docs is great. Doing performance regression testing is great, and all those things. One of the things that's really quite awesome is that we've also automated creating packages. So all of our software isn't necessarily all in Debian and Red Hat and everything. We're getting there. But we also have like our own Yum repos, our own app repos, and we do binary tarball releases. And of course, if anyone who's ever had a relationship with someone who's like a build engineer, typically, at least previously, it was like you just magically sort of point them at something and then they do some arbitrary process that's huge and complicated because you can never replicate it and get out a binary that your people use. And that's problematic because it means none of your developers are ever actually running a binary that is remotely like what a customer runs, which is wonderful when you realize that if you build for i386, a whole bunch of stuff breaks, but on i686 it's okay because there's actually a bug in your atomic instruction implementation. That's kind of fun. So one of the great things is we automated doing builds. So essentially, if we need to do a custom build for a customer with one extra fix, you can actually grab the bazaar tree and the developer says, here, I need it for this, and it's pretty much plugging in that tree into a web form, which then goes and builds all the binaries properly using the proper methods and spits them back out as artifacts, and you just download it and hand them to the customer. And this means that the same stuff is used by our build engineer, and the build engineer can now spend time doing things such as improving the Debian packaging so it could actually one day get into Debian and stuff like that, instead of constantly spending time manually massaging the process and SSHing to different machines to build stuff. So you actually do get a great benefit of simply automating all the things of being to have your people continually to be gainfully employed, making things better rather than doing the same thing over and over and over. Because one thing people can be is nervous is, will I still have a job? It's like, yes, don't worry, our to-do list is huge. You will always have a job doing build things. So custom builds at the push of a button is really awesome. We can actually get builds out really quickly, and we can also get builds out to customers with specific fixes really quickly, and that's a huge improvement. The other great thing is graph all the things. Jenkins has a great plugin for doing plots. Basically is if you can spit out XML with some numbers in it, and you can write an XPath query, it will generate graphs over builds. Which you think, well, that sounds a bit annoying. Well, XML is a defined thing, which is kind of nice. If there's one thing that I will say about M4 compared to CMake as a build infrastructure, at least M4 is a defined thing, and CMake stands for crap, because it's not defined. If you're going to have a language, define it. And so one thing I can say about XML, it can be horribly verbose, annoying to construct, and have errors, but it is a defined thing. And therefore, spitting it out is not too bad. And XPath is at least as well. And this is kind of useful. We graph nightly performance regression tests. We do staging performance regression tests. And you actually just get a graph and you see the normal bit of wobble between each individual run. But like seriously, me going through, is it okay to press the button to push this to trunk, is just looking at the graph. And that's really easy because my head QA guy completely set that up himself. Just clicking buttons in the web UI and reading the Jenkins stuff. I didn't have to do it. We didn't have to worry around with whatever GNU plot, graph is something or other else to draw stuff with it all or something. It just came out and it works. One other, I will say, major innovation is manual checklists. Our release process is a series of steps, and yours probably is too. Some of which are manual steps. It's not just like creating a tag and then suddenly everything happens. You may also want to, for example, ensure that you create a release branch. You may want to ensure that the release notes are up to date before you release it. You may want to inform your sales, marketing, and support organizations that you're about to release a new version. It turns out that what you consider a minor fix to some bug may actually be a huge thing that you can get articles in various tech publications about, and then it makes your marketing department love you, which is more likely to buy you cool things at some point. and more customers to then have more money to have more developers to get more of the stuff done. So informing the support and consulting organizations, that was a big thing, because a previous complaint was, you just released a new version, I didn't bloody know about it until some customer asked me about it, I had to go read our own website announcement for it. So at least this way, when you send it out to the internal organizations, at least as long as they're reading their email, they're aware of it, so when a question comes in, they can all say, yep, we have a fix coming out, a new version coming out with this in it and not. And we've tried to also keep the docs up to date, so we don't write release notes when you're about to release, actually write them as each thing gets fixed, so you start to have a sort of work in progress release notes that's continually merged and up on the website to what will be next. And this is all about a dozen, 15 steps. And these include things like build the binaries, upload to staging, sign the binaries, inform people about it, all these kind of things. And it's a Google spreadsheet with 15 steps. And previous to this, we kept screwing up individual steps, because with 15 steps and 20 releases a year, turns out you can actually, between a couple of humans, screw up one or two things every so often, and suddenly you're constantly making mistakes. And since then, 0. We've always hit the right things. We've actually added things for it. We've augmented it a little bit. For example, checking that the version number is correct. Believe it or not, you can get that wrong. So you do actually have a manual checking that, and sending email out, say this is the fixes. It all works brilliantly. Manual checklists are a major innovation. One thing I noticed is that the Oracle people weren't necessarily pushing their public source tree on time. It was obviously like, we have a checklist for what to do on release, and obviously you don't, and you definitely don't have pushed the source code out to public as one of those. So it is in fact a major innovation to have a checklist, and do not think you're above it, because this really helps repetitive tasks. So one question is, has all this helped? And so we can do some numbers on it. One of which is, in 2010, we did 2 extra backup releases before I joined. So that was really early in the software development cycle. It's like version 1.0 and 1.0, well, we better fix that so it works. Never used anything until version 3. 2011, we did 4 releases, and in 2012, we did 11. So at least we're able to pump out more releases with a whole bunch more bug fixes. Now it's the point that people do recommend it, it is pretty solid, and we have a much higher standard of quality of code, what's going in, and functionality and expectations of things that work. So that's really good. For Percona server releases, we've done them sooner with fewer bugs. We have a good sense of improvement. We have more developers in the code base now as well, so it's scaled up in that regard. The scary thing is, so Jenkins stores everything in a file system, and so you can search for config.xml as configuration for each job. So I worked out how many we have. We have 2,586 jobs in Jenkins, and this includes the matrix build, so each of those extra backup ones is 132 individual jobs. So it scales up to a few thousand. We have records for 36,049 builds, which is fine because it's mainly just log files on disk. We expire a lot of builds pretty soon. I've made the parameterized ones last longer because it depends how quickly you can go in code review to see what builds are going. But it handles a whole bunch of this and it's fine. The downside is there is a 3.7 gigabyte Java process on a machine, which is annoying until you realize that RAM is cheap compared to developer time, and therefore it's not worth fixing that.
That's quite small for Java.
Yeah, I know, it's quite small. But you think it's I can make it run less than that. I can do that, and you're like, it's not worth my time. Just going and patching it, just buy more RAM. That's $3 of RAM. Me telling you about that has cost thousands of dollars in all of our time that we could have bought 370 gigabytes of RAM instead. So one of the points is Jenkins does scale to as big as you probably need it to. Until you have a team doing things for you, it's going to scale. The other thing I can point at is I graphed delays in our releases. So once Oracle releases a version, because they now don't push anything but the actual release to public source control. So until they actually drop a release, you have no idea what the hell's in the next version of MySQL. And we base on top of MySQL. So here is, we say that we try and get a new Percona server release out within 30 days. And so this is for the Percona server 5.5 release. I first introduced Jenkins about here. So we had an initial huge delay, and then we had a couple that were really quick, which was fixing up that. And then we suddenly got a bit better, and we managed to stay around 30 days. Then we introduced sort of a checklist for releases, and instead of having literally a series of patches, which was not even Quilt applied, custom scripts that was re-implemented Quilt and poorly, we switched to having an actual BZR branch, so you could use like merge and the like. So we introduced BZR in a checklist there, and suddenly we had this huge drop in delay because we actually do things a whole bunch quicker. The beta graph for showing this is our Percona Server 5.1 releases. So we had a lot of delay earlier on here in earlier versions, and then there was a bit up and down. Introduced Jenkins, bit of variation, but then it started to be consistent. And so between that and using a full bazaar tree instead of series of patches that was horrific, we actually managed to get it down. This doesn't tell the whole side of the story because this doesn't tell like what tests passed when and all that kind of thing, which would be a great thing to graph if I ever bothered to really keep the numbers. Which, sorry, I didn't. I would have loved a graph for it. We did, I also looked at over time of test suite improvements. So at the same time as doing this, so introducing code review everywhere, making sure we had a gated trunk, having continuous integration running, making people build things before they proposed mergers going in, which was all gradual steps. Also saying, right, to put in code, you have to actually write a test for it, right? Start rejecting code if it didn't have a test. To the point of, I believe at one point I did actually grab trunk and merge out the last revision because it didn't have a test with it and push it just to show I was serious. Yeah, you only have to do some of these things once or twice before people realize, oh, they're actually serious. So I graphed the Percona extra backup tests for the 1.6 release series and 2.0. So you can tell when we started basically having 1.6 be a stable release where 2.0 was the main source of thing. And so this is like November 2010, the number of test cases that were in there. And this is just basically like shell tests, which is start server, run backup, stop server, restore backup, start server, can something work? So it's not incredibly sophisticated. But we've basically grown like more than linearly over time. And a bunch of that is simply due to the fact of once you clean up the test suite so that everyone can run it and it's not too hard, it becomes way easier to run that. So previously we had the problem of, hey, we had no tests, but the test suite ran quickly. To somewhere around here, it started to take a long time. And then at the end, it was like, oh my God, it's taking over an hour. This is ridiculous. We'll have to parallelize it. And this is when I've written my current favorite 250 odd lines of C, which is a parallel test runner that would probably compile on 4.3 BSD because it does great things with just simply sockets and processes and select and stuff like that. And it gives you, grabs a subunit output and then splats it into a file, and it's brilliant. This literally is one of the most productive things ever written, at least for our team, simply because when the time takes from over an hour, and then you have contention on build hosts, so it could actually take 3 hours or like 8 hours in actual time to get a full run done. When it takes each individual build down to about 12 minutes, right, where it becomes like, because we run everything with eat my data, live eat my data, best thing ever. It just disables pesky things such as fsync to make your data stay on disk. So it removes crash safety from applications, which is exactly what you want in a test suite because you don't care about crash recovery in the test suite. Well, not machine, flick it on and off. So Eat My Data was already using that, and it was still IOP contention because there was seriously just that much stuff going on. So we already did that, and then it's just basically now limited on basically, I think it's the actual ext3 journal. It's like the main contention point at a bunch of these machines and how many processes it has. But that's really helped us now execute it in much less time. And so when you can actually run locally in 10 minutes the entire test suite and burn all your CPUs, it's pretty cool. So yes, it all helps a lot. And current idea is that continuous integration helps when the number of developers on a project is greater than 0. Because you only have each person, no matter how good we are, a really good dev is going to make like one screw up that'll break trunk per year, or one every 100 days, or several. That means an average developer is going to make a lot more. Multiply this by enough developers, and it means trunk is broken all the time, no matter what. And so basically, we went from that, way back in previous life to something now where trunk is always released. Releasing is pretty much the checklist of grab trunk, ensure the release notes are up to date, inform people about it, and push it. The number of things is, oh, we have to add something to a release branch, comes down to next to none. I remember there was like one in the past year because that was like for a really big customer and it was actually finished. So that's a great benefit to us. It also helps for your own projects because, then you don't make your own silly mistakes and hurt yourself. So thank you. Or a question, or 3, or statements, or wild accusations. Yes?
You mentioned that you have a gated trunk, so you're developing on branches. How many branches do you have, and how often do you actually integrate them?
Everyone will use their own branches for their own individual features. So basically every bug has their own branch, every feature has its own branch. Basically, you almost have as many branches as you do revisions at certain points in time, because you just have one individual thing. So each individual thing goes in its own branch and therefore its own merge request, which is simple. It's like a folder on a disk. Yeah. Bazaar lets you quickly change, Git lets you quickly change, so it's not really a problem, and you just merge things up as needed. So
how often do they wind up coming together? So there's a big risk with feature branching is you're not actually continuously.
So we don't necessarily do feature branches.
Right.
We do it for some things that are bigger, and that increases code review time. But feature branches, I think, is generally a bad idea. We sort of do. For extra backup, we have done some feature branches simply because enough refactoring stuff in there, it's kind of useful, and it's like not that many people working on it. One of the current features we have going into Percona Server is actually, it is a big feature. It's for real incremental backup. So it keeps a file which is a bitmap of what pages in the database file have changed. And that's sort of a continuing work. And what we've done is continually merging it in. So you in fact develop the feature like alongside in trunk. And so the option to enable it is there, but if you don't enable it, it doesn't affect it. So pretty much it's, by the end we can go and announce, oh, this version does work, you just enable this option, and then everyone will already have that. And we don't have to coordinate as much between releases. So it's a bit of a balance. But if you do have two longer existing feature branches, it just gets hard. And so I try and make people to break it up into smaller chunks, and it's like, oh, I have to refactor this. Well, then pull out the refactoring and merge that individually. And we've done that for some things, which helps a lot too, because it means it makes everyone's merging less painful.
Long-running feature branches suck.
Yeah, long-running feature branches suck, yeah.
Do you use CMake and test and C-dash and why?
CMake is used in Percona Server 5.5 because that's what MySQL uses, mainly because that was one thing that kind of built on Windows. I have words reserved for CMake, most of which I shouldn't say while being recorded on the internet or where there may be delicate ears. M4 is brilliant. It is a defined thing. I love M4. These are words I never thought I would say until I encountered CMake. Like when you suddenly realize that debugging your build problem is actually you get to dive into a whole bunch of really poorly written C code, and as soon as you put symlinks anywhere in your path, the whole thing explodes, and that's a feature, not a bug. If you can avoid using CMake, go for it. But yeah, I don't think CTest is really used in there. It's like their own custom test suite stuff from MySQL, as it always has been. But yeah.
Is param build just that parameter build on Jenkins?
Yeah, it's just add parameters to build. So in the configuration for a job, you can just say has parameter, and then you can use those as just variables in other parts.
Okay. Yeah. It's not a separate program.
No, it's not a separate program at all.
From just approving everything going, oh, the guys who are writing this code are better at this than me, so they must be getting it right.
Because they will see other people's code review and see that they actually had some insightful comments, and they'll want to look good and productive.
Yeah.
Actually providing existing code review already there, so it seems to have enough of a psychological effect of, oh, that's what expected from me for a code review. And at the very least, they're at least looking at it. So it's some kind of learning going on there. So we have one guy who's pretty new in there, and he's like, oh, I don't know a bunch of stuff. No, he provides good code review. Reviewed some of mine recently and made some damn valid points, and I'm really annoyed because I have to go and fix them.
For my part, I discovered the value of code review the exact minute I was told I was responsible for someone else's code.
Yeah. It's like,
now I know.
I try and make it an ethos inside the company of that everyone in the company, that includes support, consulting, marketing, sales, is responsible for every line of code we ship. And this is kind of after beating our head into, there's a whole other story about relationships with support orgs, but after beating their head as well, we also got to the stage where we were able to fix things up in bugs and continuous integration, where people actually started filing bugs again, and they actually expected them to be fixed as well. And so I'm starting to also trying to grab some of them to do sort of code review. It's like, server options being sane or documentation being correct and stuff, and that's kind of working too.
Yeah.
It is probably no doubt time for Robert. So thanks again.